లైవ్ స్టార్ట్ అయిందా? Okay, guys, please turn on your cameras. It's supposed to be interactive session. లైవ్ లో మరీ చండాలంగా కనిపిస్తున్నాడు. నేను వీడియో ఆన్ చేస్తాను. ఆ లైవ్ లో చూస్తుంటే నాకే భయం వేస్తుంది. ఉండండి, వస్తాను నేను.
Then shall we start admitting the people?
స్టార్ట్ చేసి తీసుకో, వస్తున్నా. Hello guys, am I audible? So okay, today will be good evening people. Today will be a completely interactive session. Okay, so first we'll start off with clearing your doubts till date, and then we'll move on to the next segment of today's agenda. So today it will be the first 20 to 25 minutes will be explaining you the doubts you had since the past 6 days, and from now on, after the first 25 minutes, you'll get to know something exciting. Is that okay, guys? Could I get some response? Am I audible?
Yeah, you are audible.
So we'll start with day one. Do you guys have any doubts regarding the day one? Yeah, if yes, you can turn on your mic and ask your doubts, or you can post it in the chat box. Guys, let's make the session interactive. Okay, SLAM. So basically, SLAM is a topic which involves two more topics: localization and mapping. The full form of SLAM is simultaneous localization and mapping. Okay, so it is one of the concepts that we use in ROS, which is robot operating system, where we tend to localize the robot, technically a mobile robot, and map the same time. So yeah, it is a very huge thing to dive into, but I'll give you a brief explanation. Before getting to know what is SLAM, you need to know what is localization and what is mapping. So by the terms localization and mapping, yeah, they are self-explanatory, right? Could someone tell me what is localization? Someone please. Yeah, whether it may be right or wrong, it doesn't matter. But could someone please tell me what is localization? Could someone please tell me what is localization? Yeah, location of a bot. It's true. And anything more? Anyone, guys? Adaptation? Not exactly, but yeah, a part. Absolute and global path. Okay, Akash, do you have any experience with ROS? If you do, I'll change my answer. I mean, if you do, I'll give you a precise answer. So, absolute and global path are related to path planning, but not to the SLAM. We create maps, global and local maps with SLAM, but not paths. Okay, so basically localization is a topic, is a concept where we implement it in mobile robots. So if you've seen the first webinar, which is Introduction to Robotics, you might have seen the types of robots. They are broadly classified. But when we jot it down to only two categories, it is mobile robots and stationary robots, right? So whatever I'm talking about is done with mobile robots. They can be done using non-mobile robots, which are stationary robots too, but we generally tend to do these with mobile robots. So when let us say there is a mobile robot. By now you might be familiar with what is an AGV, ATV, right? Is there anybody who doesn't know what is an AGV or ATV or any type of mobile robots? Could I get a response, or are you all familiar with all these concepts? What is an AGV? Just knowing them. Some response, please.
It's automated periodic.
Okay, cool. So let us say I have an AGV. What does make a robot different from a machine? Making decisions by itself, right? So if I want to perform some autonomous actions with my robot, it should have the capability to make the decisions. Yeah, AGV is autonomous ground vehicle. Yeah. So in order to perform autonomous tasks, the robot needs to familiarize itself with the environment. That is the first and foremost thing the robot should do. So let us say you have a robot and the robot is in your house. You have the map of your house, that is the blueprint. You all know what is a blueprint, right? So the blueprint of the house, let us say there is nothing dynamic in the environment. So the robot will be moving from one position to another position. So basically, yeah, in order to move from one position to another position, the bot needs to localize itself within the map. That is called localization. So the ability to anticipate its position and orientation within the given map is called localization. Whereas mapping is when the bot is moving, it is sensing its environment and generating a map. To explain it in a very basic terms. So in order to perform localization, we need a map. In order to generate a map, the bot needs to localize itself. So is there a way to do this simultaneously? Yes, and that is what called SLAM, simultaneous localization and mapping. So combining the both, getting the best of both localization and mapping. If you do it simultaneously, it is called SLAM, which we generally use in ROS. ROS is nothing but robot operating system. Yeah, that's it. Who asked the question? Akash, right? Is your doubt cleared, Akash? And any more doubts, guys? Yeah, ask us anything. Chill.
You're in mute, Anna, Karthik.
Yeah. Any other organizer ready to take this? What is a servo control bot?
Yeah, Karthik, if you say, I'll just take it up.
Yeah. Go with it.
Hey guys, there's nothing called a servo control bot. Actually, what is servo is an actuator. Generally, servo is actuated because, like, servo does the action what you send it through what do you say exactly? I'll exactly specify it in such a way that when you want to move your hand just moves, but your hand can't control your whole body, right? Similarly, in that way, a servo is a type of motor which has a feedback. Generally, what is a feedback is nothing but getting the output from the work which we have done. That's it. Like you're having some work. You kept a hot pan on your stove. You don't know whether it is hot or not. When will you know it is hot? When you touch the pan, you get a feedback that it is hot, meaning that whatever you turn on the heat, it has observed. Like that feedback is nothing but whatever response you're going to get it. So generally DC motors and all, what happens is when you have a normal motor, it just runs. It doesn't give any feedback. That is, it doesn't give any response back. Like I have moved this much of distance like that. But when a servo has rotated, it produces the angle. It sends the microcontroller with its angle. Like it will tell after reaching a particular degrees, I have turned 15 degrees. It will send its command back to the robot. So actually, there's nothing called a servo control robot. What you meant to say is a bipedal bot or something. Like for walking or other purposes, you use a servo as an actuator. Like servo can't control your robot. Like it doesn't have a sensor. Like it doesn't take the what do you say? It doesn't have any. It is a dead reckoning sensor. Well, dead reckoning means it just tells the state of the robot to itself. That's it. While environment sensor is something like active sensor is something like which takes information from outside the environment and only a bot can be controlled using a microcontroller or a microprocessor. That is a mind. Like your bodies can be controlled using a mind such a way. Whereas our legs or hands can't control a body, right? That's the main difference between that. Anything which has to be done is only controlled through a microcontroller MC unit or an arithmetic logic unit. That is a programming unit through which you program the bot and you will specify it. You have to move this much of angle, and how will you know how much of angle it has moved? There will be a feedback coming back from the servo. That is, the servo will be giving back to the robot, telling that I have moved this much of distance from this point to this, like that. This angle I have rotated in such a way. Anything more you want to get clarified on this? Please put up, or just we can hear your voices. Is it clear?
Guys, it would be better if you just turn on your mic and speak up. Yeah, we even appreciate it. Okay, moving on to the next question. Anything you want to ask? Get all your doubts cleared regarding the first 6 days. Whatever doubts you have, you can just ask now. If you are fuzzy about a certain topic or unsure what, or you didn't understand it properly or missed any session and wanted to learn any topic, you can just ask us now.
Yeah, Akash Yadav. Yeah, I'll take it, Anna.
Yeah, sure.
Yeah, Akash Yadav. Like, what is reinforcement learning? You know that, like, in the sense, reinforcement learning means by taking the conditions on the environment conditions, whether if the condition is true, then we'll increase the positivity, and if the given condition is wrong, then we'll mark it as negativity, right? Based on the situations in the robotics, when you consider the situation in robotics, if the robot is in a situation to find the whether I am taking the decision, if it is right, the reinforcement will add, and if the decision made by the robot is wrong, then it is take it as a negative, and the reinforcement learning is happened there. Basically, reinforcement learning is take in the sense of true or false, right? Did you get me? Did you guys understand? Yeah. In that sense, it will help in the robotics domain.
Let me give a practical example about that. You have a controller unit or something. What do you say is you have your bot moving in a particular environment. I would say my mobile robot is moving forward. But what is happening is my mobile robot is not moving straight. It is deviating from its path. I don't know how much deviation it is taking from my path. So I have to tune it based on the response got from my sensors. How do I do it? I'll be using reinforced learning. I can use reinforced learning in such a way where I can tune my controller unit in such a way that depending on the feedback I got from my sensors or the output I got from my sensors, I'll just use that as if it is going this much, you just change the data values or reinforce it like that. You got doubt or it's clarified? Guys? Oh, it's good to hear voices if it's possible. Yeah, continuous path control. Yeah, that can be achieved.
Yeah, 1 second. Guys, we plan this interactive session so that you'll get to know more from us rather than teaching. This interactive session will kind of help you to generate discussion, have some productive talks. So yeah, I highly suggest you to please unmute your mic and ask the questions. moving on to the next question.
Yeah, guys. Till now we completed about kinematics and sensing and perception, microcontroller and microprocessor, etc. Any kind of doubt you can ask.
Yeah. Is that it? So is everyone clear with what they've learned?
Hello, Anna, can you hear me?
Yeah. We can.
Okay, so I have a doubt. Like we have studied various microcontrollers, sensors, and motors, and all of that, right? How do we know if any of these components is not working, and how do we test them individually, and how do go about that? If any of these components is faulty in a robot, then it's how to find that out easily.
So you're from which year?
Going to second year.
So you finished basic electronics lab, right?
Yeah, sort of.
Okay. So when let us take you have an IC. Don't go with all the sensors and all. I'll get there, but we'll stick to basics right now. So how do you know that if an IC is not working? We'll first check whether it is getting proper power supply or not, right? And is it working according to our desired factors? So there comes a troubleshooting skill. In order to, that is for basic electronic components. But if you want to know whether a sensor is working or not, or whether the microcontroller is working or not, but basically you can see it. Let us say you might have studied about ultrasonic sensor right now. I mean, in the sessions, right? So you
Yes.
know how an ultrasonic sensor works. What does it give? We generally measure the distance between the sensor and the obstacle, right? How do you know if the sensor is not working? Basic rule, the output won't be generated. If a sensor is not working, respective output from that sensor, it won't be shown. If you go with humongous robots, so yeah, taking an example of an industrial robot, you equipped a sensor with it within the range of the robot or within the robot. If it is not working, the way the robot functions obviously matters. It deviates from its desired output, right? So if you go with the conventional robots, it is that case. But when you go with the industrial scale, you'll be having a concept called digital twins. You'll be emulating how the robot works in real life, in the physical situation, into the simulation. So if something is working in simulation and not working in physical space, or vice versa, you'll be knowing the difference, right? And the factor or the piece of information that we are retrieving or publishing will be affected. So based on that, we can know whether a sensor is working or not. Or else, if you are working with hobbyist robot kits, how to check whether a sensor is working or not? First, check whether it is getting proper power supply or not, and then see its parameters, the sensory data. Verify the sensory data. If it is fine, you're good to go. If not, then some problem is arised. I hope that cleared your doubt. Or you need more explanation?
Yeah, thank you.
Anyone from the team like to add any points, or shall we move to the next question?
Sheldon, Preeti, okay, I think just wait for the doubt session to be concluded. So we can have the rapid fire where we can ask you questions and we'll know you understood. Is it okay? Just put a thumbs up.
Moving on to next question. Anything, guys? Any doubt regarding robotics? You can just shoot it at us. We are ready to answer, and we are even eager to know how much you've explored these 6 days. Hello, guys. This is supposed to be an interactive session. At least type your doubts in chat box. No doubts? Then I hope you all are clear with what you've learned. Shall we move on to next segment? At least respond something regarding this. Yeah, this session is going to be very interesting, especially intriguing. Yeah, I promise you that this will definitely make you think. So by the end of this interaction, you'll get to know how to design a robot. I mean, a vague understanding of how to design a robot. So are you ready for this? Some response? Hello? Am I audible? Yeah, guys, we have around 20 plus people right now. We all are going to take part. Cool. Okay, moving on to the next segment of the session. This is going to be completely interactive. When I say interactive, you'll think and you'll respond. Okay. So by now you might be knowing what is an actuator, what is a sensor, what is a controller, what is a processor, right? And yeah, basically the kinematics part. SSLV sensor failure. Okay, I'm not keeping up with the current news right now. If anyone is keeping any tabs on the current Indian space things, you can take up. STM32 versus Gypsum. Basically, each have their pros and cons. Krishna Narayanan will circle back to it. Coming to Akash Yadav's question, each have their own pros and cons. So whenever you want to select a controller, it is completely based on the application and design of robot. So yeah, the number of ports, the memory, how we are managing how the memory management is going to take place in the microcontroller, and what type of computation you want to perform with the controller. All these factors need to be considered, and based on that we are going to select. I mean, I can't just tell is a manipulator, I mean a manipulator versus an AGV, which is better. So based on the application, we need to generate which one, I mean we need to select which is suitable for the application or the work we need. Am I clear, Akash? If you want to know further, you can ask Keshwan. He is very good at controllers. If you guys have any more doubts, you can post it, or we suggest you to turn your mic on.
Yeah, Akash, I'll just get back to you. STM32 versus Jetson, which one is better? Obviously Jetson Nano, which has a lot of processing power. Yeah, Jetson Nano has an graphic card interface, but STM32 is too. What do you say? It's something like its processing power is too low. What do you say? Like the processing power is up to. Yeah, I can say that Jetson Nano has a gigahertz, while this STM32, I think it's a Arduino microcontroller belonging to. I think it's a 32-bit ARM processor, right? Yeah, I think it's a 32-bit ARM processor. So ARM processor, like 32-bit ARM processor, while a Jetson Nano has a 64. It is comparable with a 64-bit ARM processor of a Raspberry Pi. So obviously STM32 is lower than Raspberry Pi and it is cheaper. As it is cheaper, also you can know that Jetson Nano is used for high-end projects like STM32. You just require it for minimum where you don't require autonomous navigation of parts, where you just require PWM signals which are less and all. While when you're going for the higher applications, like when I want to map my background, I have a lot of data. There's a lot of data which can't be processed with the exactly what frequency it has. I think so about kilohertz frequency. That kilohertz frequency of the microprocessor is not enough for my application because I have a lot of data and it has to be processed continuously. So I need a lot of speed. Processor is not enough for my. Why is my voice echoing? Karthik, is my voice echoing?
No, not for me. Guys, anyone from the attend is his voice echoing?
Yeah, now it's clear.
Yeah, Jetson Nano. Yeah, Jetson. There are different versions. Jetson Nano, Jetson Xavier. These versions they are used for highly autonomous vehicles. Like they are mainly used for graphic user interfaces. Sorry, graphic card interfaces. Like when you have a depth camera or image processing, you require a lot of image processing nowadays because these days the technology has grown a lot. Like you have an Intel RealSense camera and kinetic camera and many cameras which are mapping using a 3D depth cameras. These depth cameras are used for the mapping of the environments. So for those things, you need a graphic card. So for image processing, obviously you need a graphic card. Hence, Jetson Nano is a lot better than STM32. But if you're using a very small project like an obstacle avoidance bot or very minimal bots, don't go for Jetson Nano because nowadays it's become very costly. The development kit and all it costs around 33,000 nowadays. So while STM32, I think it's just around 400 or 500. So it's better if you're going for hobbies, just go for that. While you're going for prototypes, then go for Jetson Nano. Before that, try it with Raspberry Pi. Yeah, Akash, it's okay. Akash, you can interact.
Yeah, man, you've been asking very nice doubts. It would be better if you just unmute yourself and speak up. Shall we proceed to next question?
Oh, 1 second, Tarun. Are you asking what a small satellite launch vehicle is, or you're asking about the sensor collapse? Tarun?
No, above there was a question regarding SSLV sensor failure. So for that I was replying like if it was small satellite launch vehicle today, what happened?
Yeah, Tarun, actually this sensor failure, it has occurred due to the electronics department of that. The problem was these sensors, they were not, there is an issue, like there's an interrupt exception occurred due to the sensor failure and that was not notified to the system. Like there are few interrupts which are exempted, low level interrupts, and such a low level interrupt caused the sensor failure in this system. Like they didn't recognize that because they have a lot of other data to be processed. So the hierarchy of this sensor was very low. Hence there was a system sensor failure by which rapidly the other sensors which are collaborating with this sensor. Like when you want to launch something, there are many sensors with that rocket, right? Like only you don't have a single sensor working for the whole bot, right? So there were different sensors and they were arranged with different hierarchy. Like you have a heartbeat sensor that, for a person, you have a pacemaker, right? In a pacemaker, the heartbeat is the main interrupt. While the battery charging, those are also main interrupts, power interrupts and all. What do you say? I can tell you that hierarchy is nothing but this is more important than the other sensor data, like that. So in that hierarchy, they missed some interrupts, and apparently it has led to a collapse. So nowadays there has to be a committee and everything has to be mentioned. So
Yeah, no, like I thought you have missed the question, so I thought I will be like
okay. You can answer if you have any answer with that.
Yeah, okay.
I am very good to learn.
Yeah, nothing. I mean, like I actually even not clear with the answer. Thanks. I mean, like I was not clear before you explained. Now it's okay. Thank you.
Yeah. Any further doubts? Come on, guys. If you have any doubts, just post it. If not, we'll move further. So the time is 6:47. We'll wait for another 3 minutes. And if you have any doubt, we'll go with the doubt, or else we'll just proceed with the next segment of the session. Is that okay? Yeah, guys, we need responses. Cool. Instead of typing, you can just unmute your mic and just ask us. In meanwhile, team, if you have anything to address, you can move forward. The dais is yours.
How many of you guys tried with the stimulation part? Like on that day 4 we explained on the Tinkercad. Anyone tried any stimulations? With different sensors?
No one? Nothing? So, yeah. The point of, guys, the point of conducting the summer school is not just to teach the community what is robotics, how to get into the field, but rather it is an initiative taken up by the Robotics Club of Sastra to get you guys into the community, that is the robotics community. So the best and efficient way to learn robotics is by doing. If not, yeah, just try something. Take an Arduino, connect some sensors, experiment it. If you don't have the access to actual hardware, you can make use of the simulation softwares. Yeah, I highly suggest you to get use Tinkercad software, program it. Then you'll get to know how. Then you'll get your way around when you have the actual components. Okay. Still 1 more minute left to move further. Yeah. Any more doubts? Any doubts to be clarified, or is anyone fuzzy with the concepts that you were taught earlier? You can just ask us. We are here to help. To find degrees of freedom. Okay, for this you might need a pen and paper. Generally, if the structure is a bit simple, you can just see it by number of joints, number of freely rotating joints, I mean freely moving joints. But if you want to go with the formulation way, there is a formula: number of constraints minus higher pair minus lower pair, 2 into higher pair minus lower pair. So, if I'm not wrong, that's the formula. So based on the structure, whether it is closed or open, and the type of pair and the constraints within the movement, we'll be calculating the degrees of freedom. So what's this question? Vanilla, may I know which branch do you belong to? CSC. Cool. So probably you won't get this in your curriculum, but yeah, calculating degrees of freedom is completely based on 3 factors: the number of links, and number of higher pairs and number of lower pairs. Yeah, if it is a basic and simple structure, you can calculate the degrees of freedom by calculating number of joints. But when the structure is intricate and complex, you need to use a formula. I hope it's clear. Anyone from the team? If you want, you can just put up the formula.
Oh yeah, there's a formula for that, which is something like the number of joints minus the number of joints minus the number of links minus 1 into the space which you take. Like what it is, if you are taking a x, y, z axis, that is what he kept is something like for the 3 degrees of freedom. That is a mobile robot which is having only 2 dimensions, while when you go for the space coordinates, that is x, y, z direction, there are total 6. So that will be 6. So it will be 6 into L minus 1 minus 2j minus h, I think so. No, just say that. Yeah, 6 into L minus, that's the number of links minus number of joints minus 1 plus, that's it, plus the total of higher pairs. That's it. Oh, you're telling it in higher pairs. Yeah, Karthik, you just take it on.
Cool. So, okay, guys,
the formula is different because for different applications they use different ones. That's it.
Cool. I hope it's clear, guys. Okay, now let's move to the interesting part. See, guys, I promise you this will be a great learning part and interesting ones. Only if you interact. If you are not interacting, yeah, it is just another online class that you take regularly. Okay, so it is up to you whether you make the session interesting and interactive or not. So moving on to the further session, I'll give you a situation, a real world situation. So let us say you all are roboticists, and I want you to think like a roboticist based on the 6 days knowledge. If you miss out on some points, it's not an issue, but yeah, till date you've learned what is a robot. I mean, the introduction to robotics, microprocessor and microcontrollers, sensors and sensory perception, and what is the 4th day? I guess the practical session, which is simulation and actuators. Yesterday was kinematics, right? So I want you guys to utilize the concepts that you've learned and apply the same to the situation I give you. So you think you all are roboticists and you need to engineer stuff. Does everybody know what a table fan is? A table fan. If you don't know, yeah, you can just type in the message box. Or so I'm assuming everybody know what a table fan is, right? So the structure of table fan is you'll be having a fan encased with some metal casing with 3 or 4 switches, which can be used to control the speed, right? And a power socket and a plug where you'll be giving the power. So this is the basic part. Let us say, okay, first of all, is the table fan a machine or robot? And guys, I forgot to mention, there will be again a special surprise for the people who are very interactive here. The special surprises that we announce every day will be told on the last day of the summer school. Okay, could someone open up their mic and tell why it is a machine, not a robot? Yeah, they'll get the special prize, special surprise.
Because it does not
Could you
have
please say,
self-ability.
could you please say who you are? Like, start with the
I'm
previous
Sharon.
kid. Okay, hi Sharlan.
I'm a first year student going to second year. BCSE student, and my answer is it does not have any self-thinking ability.
It doesn't have any
Self-thinking ability.
self-thinking
ability.
Okay. And anything more? Apart from self-thinking ability, is it lacking anything to be a robot?
Hello.
Yeah, someone from the team.
Hello.
Yeah, who's this?
सो जो मशीन होती है ना वो एक ह्यूमन टास्क, एक स्पेसिफिक ह्यूमन टास्क परफॉर्म करती है, बट जो रोबोट है वो ह्यूमन की एआई के ऊपर जो है वो वर्क करता है. तो जो रोबोट्स है वो ऐसी मशीन है जिसके अंदर एडिशनल फीचर्स हैं और ज़्यादा फंक्शनली है एज कम्पेयर टू मशीन्स. तो हम रोबोट को एक मशीन बोल सकते हैं लेकिन एक मशीन को रोबोट नहीं बोल सकते.
What you want to, I appreciate the answer. What you've told is correct, but every robot can't make use of the AI part, right? So yeah, your answer is absolutely right. But if you could rephrase it, it should be we won't take AI into consideration. So any self-thinking, or I'll get back to you, Sharma. So any robot which have the 3 ingredients, I mean any machine which have the 3 ingredients is called a robot. I'm just giving you the hint. Yeah, Sharlan, raise your hand.
Like it does not respond to the changes in the environment.
Sorry, I'm so sorry, Sharlan. Your voice is fumbling. Is it for me?
Yeah, there's an answer.
Everybody?
Vinila Hamilkonda. It can sense and think, so it's a machine. She has answered it, I think. Vinila answered it.
Okay. True. Yeah, it can't sense and it can't make any decisions and act according to the decision.
Cannot act according to the situation.
True. That's also true. Okay, someone from the team, could you please make note of the people who are interactive and giving answers? Okay, exactly. So it is just a machine because we'll just connect it to the socket, we'll power it, and if you press on the key, if you press on the button to specify the speed, it will just rotate to that speed, right? It doesn't do much. It just performs a specific action which it is intended to. But okay, so now we all are clear that a table fan is a machine, right? Some response, guys, again. Okay, cool. So with the knowledge you have, or the knowledge from the past 6 days, I want you guys to change the table fan into a robot. What will you do? Stick with the basics. Don't go to the complex structures or complex controllers. Don't go with that. I want you to convert a machine into a robot. So the machine which is given to you is a table fan. How will you change it to a robot? take time, take 4 to 5 minutes time. We'll wait, and yeah, someone please come up with an answer. And yeah, we can have a very great discussion if you come up with nice points. So what is the time? It is 7:01, right? So again, I'll ask you the same question at 7:05, and if the person who comes up with the not perfect answer, at least a better answer, which is enough to say it as correct, will get the same special surprise. So we are thinking of 3. We already finished 2. Yes, Sherlyn and Vanilla, right? So this would be the final one. So the person who comes up with an answer, I mean a better answer, will receive a special surprise from us. Is that clear, guys? I think I've hogged a minute. Okay, take time till 7:06. I'll just get back to you by then. If you want me to repeat the question, I'll repeat it. Does anybody want me to repeat the question for a better understanding? You can ask me questions. In meanwhile, you can ask me questions. So the question is, we know what a table fan is. It is a machine, right? The machine, a table fan, we consider table fan as a machine. In order to convert it into a robot, what is the approach you need to go with, or what measures are to be taken? This is the question. So the person who comes up with a better answer will be given a chance. Yeah, it is a chance. I won't tell you how we convert a table fan into a robot, which is essentially a machine. Conversion of a machine into a robot, the machine is a table fan. Okay? Yeah, please come up with an answer. Again, I'll ask you the same at 7:06. Meanwhile, if you want, you can ask me questions. But it would be better if someone gives a structured answer based on the fundamentals of robotics. I'll give you the structure. How will you convert it as a robot? So in order to qualify as a robot, what are the attributes it needs to have, and what components are you going to use, and how will be your approach? Using IoT, just right click voice command to understand. It could be one, but I'm seeking an answer in a more specific way.
We can use a microcontroller instead of a switch, and we can also connect with a voice recording to make it an interactive as a robot. To make sense like a robot. If we can also control with the voice recording.
Let me clarify one thing. If you want to interact with it, there is a separate concept in robotics called HRI, which is human robot interaction, where we will be embedding all the basic components, and an infrastructure is created there where the robot and human can interact with each other. So yeah, again, don't go with complications.
So actually, I just thought of saying it, how to change a fan into a robot. I thought, so I said, I don't know whether it is right or wrong.
Cool. There is nothing called right answer or wrong answer here. The only factor that is measured in this session is how close you are to the basic approach. Okay, let me put it in this way again. you are again a roboticist. I'm a person. I'm a lazy person, which is true in real life too. And I don't like to turn off my fan, which is a constant issue I face in my life. So when I'm present in the room or within the range, the fan should turn on. If I leave the space, it should turn off automatically. So it is an application. It is an application of robotics. I'll just give it away. If this is my case, what will be your approach? Yeah, sensors, guys. You need to be more specific. I can say I'll just convert into a robot by using so and so, but it would be better if you just give a precise answer, precise and more or less accurate answer. I'm getting too many responses. Could someone from the team keep a track of the answers?
Like, can I try answer?
Yeah, sure.
So the infrared sensor detects thermal signatures, right? So if I keep the table fan in a room, it should be able to detect the number of people in that room and where those the position of those people in an exact manner. So the speed of the fan blades changes according to the number of people in the room, and also if there is only one people in the room, it should be able to detect in which direction that person is, and then change the direction of the fan blades accordingly. So there's a direction changing table fan, right? It just swings from left to right and does in that manner, right? So it should be able to detect where the person is and then provide the air.
Okay. So Venkatraman, you decide how should I counterpart that. Now we are just interacting, right? This is an interaction session. So how you want me to counterpart what you've said? Obviously, there are few constraints with what you've told, and I appreciate the approach. There are few there are few constraints. So how do you want me to go? In an easy way or a better learning way? The better learning way will be a way where I strip down your whole idea and make you think why you said this. I mean, not in a harsh way, but yeah, it will completely change your perspective of your answer. Venkatraman, it's your call. Okay, I'll go with the easy way. So you said you'll be using an IR sensor, right? Obviously, it keeps track of heat radiation within its proximity. So when you take that, there are two things you need to focus on with respect to the sensor, which are the field of view and range of motion. Field of view in the sense, what is the range of the IR sensors, the perception, and how you'll turn the fan. I'm just a lazy person, and yeah, I don't know. It doesn't matter how many people are in the room, right? If you are using a table fan, it is up to you. It is mostly for 2 to 3 people. So what if I want it to the maximum speed? But since I'm the only person in the room and the IR sensor detected I'm the only person based on my heat rays, and I'm unable to change the speed. So what is your take on the approach? Your same approach. This works with a generalized way, but as a roboticist, you need to think. You need to think better. Just pushing you to get a good answer. We have something from Himanshu. Servo motor, then we can set servo fan. Sugar shaft AC motor. Vanilla, what part of my explanation should I repeat? Himanshu, your answer is great. Okay. Let us say I'm the only person in the room. And the fan is turned on. By some means, the fan is turned on. But since according to Venkatraman's approach, we are calculating number of people in the room based on the heat traces, and then we are setting the control, the speed control. So I'm a person, it's a hot summer day. I want my table fan to rotate it at the blades of fan should rotate at full speed. Since I'm the only person, it is rotated to certain speed. So what should be the approach? It is the question I've asked Venkatraman related to his approach. Coming to Himanshu's, we can use servo motor, then we can set servo angle to 90. Okay guys, I have one more doubt. If we are going with the heat traces, why don't we use a temperature sensor? Did anybody get this idea? I would appreciate if somebody got an idea of using heat temperature sensor. Anybody, could you please raise your hands? Okay. So anyone from Sherlin, anyone between Sherlin or Vanilla, could you please turn your mic on?
Yes, I'm Sherlin.
Yeah. So okay, Sherlin, you thought of using a temperature sensor, right?
Oh, yes.
Yeah, I appreciate your approach, but where are you going to place this temperature sensor?
To control, to sense the temperature of the environment.
Yeah, I mean, I understood that, but where are you going to place the temperature sensor? Is it on the fan, in the fan, near the fan, far away from fan? Where are you going to place the sensor?
On the upper surface of the fan.
Don't you think the rotation of contact sensor? Okay. Don't you think the temperature around fan is a bit colder than the temperature of a room? I mean, based on that, there might be some deviation within the temperature sense, right?
Yeah. So,
Then how are you going to deal with this?
We have some errors to like plus or minus 5%.
Sorry, Sherlin, again, your voice is too fumbling.
It may have some errors like plus or minus 5 degrees.
Okay. So you're okay with having some error tolerance, right?
Yeah, but with a minimal tolerance.
True. That's an approach. Yeah, I appreciate it. Good work. We can put it behind the air intake wind point. Yeah, but isn't the motor hot enough than the? I mean, when the motor is rotating, some heat will be dissipated, right? So wouldn't that affect the temperature sensory data? No, this is just a hypothetical question. I mean, there will be tons and tons of constraints if we go on. I'm just making you guys to think. To be honest, there is no proper way to approach.
I think I have an answer for your doubt that you asked.
Yeah, sure. Okay.
So the approach shouldn't be based on the number of people, but on the amount of heat that is detected. Okay. So automatically, if one single person is feeling very hot, automatically his temperature will rise, right? The heat signature will be higher than usual. So that will automatically instruct to increase the speed of the blades, even if it is just one person.
Okay, but how about the temperature within the room? Wouldn't that affect the IR sensory data? What if the temperature within the room is higher than my body temperature? I mean, it's a case, right? Did you understand what I'm asking, Venkatraman?
Yes.
Then what will be your approach? Okay, I'll give you some time to think. Anyone other than Venkatraman, Sherlin, Vinila, Himanshu. Did you guys think of any other approach? See Avantika's responses other than these guys. Yeah, guys, interact. Just though it may be silly doubt or a silly approach, just ask it. If the frequency of you asking determines the knowledge you are procuring, I mean that makes you think, right? Why my approach is not proper, or is there any constraint in my approach? How should I develop it? As I guess everyone's studying engineering here, as an engineer, our main goal is to go with the efficient and low cost products, right? So yeah, think as an engineer. Any thoughts, any approaches? Okay, could someone tell me what are the three major ingredients or attributes that a machine need, or any entity needs to have to consider as a robot? The three main topics. I guess you've learned this in the first webinar.
Sensing, perception, and action.
Precisely perception, sensing, decision making, and action. So just think of only three components. So anything that needs to be considered as a robot should possess these three characteristics, right? The ability to sense, the ability to make decision, and the ability to act according to the made decisions, right? So just think of any three things that you want to implement in a table front to convert it as a robot. Just simple. Don't go too complex. I mean, don't go with too complex solutions. Again, I'll give you 2 to 3 more minutes. We'll wrap up the sessions. Okay, sensor control system, manipulators. Okay. I don't know why manipulators came. Avantika, like, could you please explain why a manipulator came into the scenario? Okay.
To just interact with the environment, but it's not necessary, I think, manipulators, but just to interact with the environment.
Could you please specify in what way you want the manipulator to interact with the environment? I'm actually very curious to know. Yeah, take your time. Sherlin.
Sometimes they are required to move objects from their environment without the direct contact by human, I think. I don't know whether it's right. So
as I said earlier, there is nothing like a right answer or a wrong answer. The way you approach to the given problem statement only matters. In fact, you are making progress. At least you are, whether you are near to the approach or farther away, you are making an effort. That is what matters. Okay. So basically, a manipulator will be used to manipulate the objects. Manipulate in the sense pick and place, grip, or move from one position to another position. Basically, a manipulator is a robotic arm to take something, place something, or perform some objects, some object manipulation, such as painting. If you see in the assembly lines, you can fix screws, you can paint the frames, or you can weld. These are few of the applications of manipulators. When you think about object manipulation, we need to go with a manipulator. Yeah, but though your approach is a bit new, cool. Actually, I'm not getting any words to express this. But yeah, I like the way you've gone. temperature sensor as discussed, actuator. Basically, an electric motor is an actuator too. So how are you going to use the same electric motor to convert it as a robot? Just adding a controller and a sensor doesn't do the work. Adding the appropriate ones and specifying the job is what matters. Microcontroller for memory of previous actions taken by the user. You can use, but yeah, Sherlyn, I suggest, if your voice is clear, it would be better if you just open up your mic and speak. You want to have the live interaction rather than reading your messages. Okay, cool. Certainly not. I don't want to.
Just a second. I want to make this clear, guys. It has to think itself. A robot has to think itself. It has to produce something of its own. Okay, such a way as it has to work on its own. Like when we are giving signal, it's working not like that. It has to think its own in such a way. There has to be some data manipulation involved in the controller. Yeah, previous answers were different. That's why I wanted to tell this. Yeah, Karthik, take on.
So yeah, just implement a simple sensor, a controller, and control the actuation. Okay, I'll give you a hint, or I'll just tell you the basic thing. I'll use a sensor which is fixed in my room somewhere where it can capture, where it have the optimal range of field of view so that it can capture the sensory data. Precisely a PIR sensor, then send the sensory signal to the controller. If something is detected, see, the point of taking a table fan is we'll generally fix it to a position, right? When say you are sleeping, you'll fix the table fan at a certain position where your whole body or certain part of your body gets the cool air, right? So when the position is fixed, controlling the motion shouldn't be a huge problem. So let us consider that the position is fixed. I'm placing the table fan at the same position. It is connected to a switch. What I'll do is I'll just take a sensor, a PIR sensor or an IR sensor. If I'm in the room, okay, I'll say that I'll fix a sensor above the room, where it can capture the heat traces of the whole room, and one near my sofa. If someone is there, it can be me or someone. If someone is there, it senses my heat radiation. A pulse will be going there. Since the table fan will be having switches, right? You can just push them to set the speed. I just set the speed using some key debouncing techniques or a servo motor to to fix the control. Simple. Even though what I've said, it can have tons of constraints, I just want to stick with the basics. And the reason why I'm always constantly posing the constraints with what you're coming up is I'm just trying to push you to the extent where you can get a better idea, so that you'll think of new ways. Now again, take 1 or 2 more minutes, think of another approach, and could someone get back again? If it's clear, if you're okay with it, we'll continue the session, or else yeah, it's up to you. We can wind up, we can stop this. Guys, should we move further, or is it okay if we wind it up? Some response, please. Yes, for okay, we'll continue. Cool. Now take a minute or two, come up with a new approach. So first of all, is this intriguing? I mean, is it interesting, or should we change the topic? Yes, for what should we change, or is it interesting? Okay, cool. If not, if you are bored with this, I'll try to think of a new application to give you. Simple. You can work on it. Okay, cool. How many of you want a new application? Please raise your hands. Adding timer to its processor by using microcontroller, like alarm clock, switching it on and off at the right time. Yeah, it can be a simple approach, but essentially it is still controlled by a microcontroller, right? What does it make a robot? I mean, I can turn on and off my LED bulb at certain times, but does that make my LED, or does that make my LED bulb a robot? Did you get my point, Abhijit? You want a table fan to be? Okay, cool. Okay, I guess you guys are bored with this. Let me think. Okay. Why don't you guys give us something and we'll work on it together? How does that sound? So you've already seen one application, right? Why don't someone come up and give us a problem statement? We all can work together. Or anyone from the team?
Yeah, let's just make it generic.
Okay.
I want everyone to develop a simple solution. Like there are many home appliances or anything which you see around you. Try to convert it into a robot. Like what happens if it's a robot? I want different answers from each of you, and the most one will be highlighted. The most intriguing one will be highlighted. Is it okay?
Combination of sensor. Yeah, you can. I mean, it is your approach. There, as I told, there are tons of approaches, tons of constraints. It is up to you how you like make up a solution.
Hey, Karthik, is it okay like that? We can give a generic statement. I want, or we can find a new solution for different things.
We can. Why don't we use it to our LinkedIn session?
Yeah.
Anyhow, you guys should post what you've learned, right? So yeah, think of a solution. Think of a solution and post it. We can have a discussion in your LinkedIn session. I mean, many people can come up there and give their views. Okay, so Yashwant, we'll continue this session with your approach. And regarding this, turning a table fan into a robot. This should be your headline in the sense the main title. And what is your approach? And anyhow, you should be expressing what you've learned, right? This time, today, why don't you just post what you've applied based on what you've learned? And yeah, obviously, myself, Yashwant, and few people from the team will definitely come to your message box, or if you're okay with texting us in the message box, we'll definitely like come there and we can have a discussion. So this can pull our connections, your connections to see what you've learned, and they can also express what they think of the problem statement and a solution. At the end of the day, who knows? It can be a new product. Is that okay, guys? Hello? Any response? Yeah. The main reason to ask you to post in LinkedIn is you'll get new connections, you'll know people who are into robotics, and yeah, it will make you consistent. Cool. Then we'll plan. Okay, then post it. We'll have a discussion. Yashwant, you can continue with your approach. Yashwant, you there? Hello, guys, am I audible?
Yes, sir, now you're audible.
Is Yashwant there?
No, Ashwantana is not there, I guess.
Cool. So, hello, team.
Yeah, bro. Yeah, you're audible.
Yeah, could you please tell me what Yashwant said? There was a bit of lag in my connection previously.
He says that like we can generate some multiple solutions for, like, as you said that example, right, as a table fan like that. He says that like other things that we can able to make a robot like that.
Cool. Okay.
From the components we daily see and use, and like the home appliances, how can we make them as a robot? So make up new ideas. Anna said that.
Okay. Sticking with the home appliances, it just eventually return us to this smart home automation. But yeah, ultimately they are just IoT applications and appliances, but not considered as robots. Most of them are not considered as robots. Okay. Let us say, like, everyone know what an AGV is, right? Hello. Okay. Guys, please respond. I mean, I can't always check the chat box, right? So is an AGV a robot or a machine? We have a normal car, right? Is it a robot or machine? I just asked, is an AGV robot or machine?
Machine.
No, AGV is a robot.
The normal car is a machine.
Oh yeah, a normal car is a machine. It is a machine of various systems, to be precise, but yeah, essentially it is a machine. So is Tesla considered as a robot or machine? Did someone already ask you this, or this is the first time you're hearing this question? So did any of my team already ask this, or is this the first time you are hearing this question?
First time.
Did they ask earlier? Okay, cool. Cool. I'll just rephrase it. So Tesla is a robot, right? So we all agree upon these two statements. Explain on workshop. Okay, did I? Okay, cool. Vanilla, then could you please stay silent for this session? I guess you already have the answer. Okay, cool. So a Tesla is considered as a robot, whereas a normal car is considered a machine, right? So we all agree upon these both statements. Am I clear, guys? Okay, cool. I'll give you a condition. Let us think of a hypothetical situation. There is a road, a straight road. Both Tesla car and a normal car are moving at same speed. They were accelerated till 100 kilometers per hour. So at the current position, at this time instance, the speed of the car is 100 kilometer per hour. Is that clear? And it is constantly decelerating within some time frame. So it is going 100 from 100 to 0 at the same rate, both Tesla car and the normal car. Let us keep aside the aerodynamics, the resulting, the frictional forces, all the forces. Hello guys, am I audible?
Yeah, you're audible.
Okay, cool. So we'll 1 second. We'll keep the aerodynamics, the resulting frictional forces all as constant. They are not affecting these both, the deceleration of both cars. So at that point, are both Tesla and normal car machines? I mean, they function the same way. No, let us say no, any sensor is not triggered or nothing happens. So they are constantly decelerating from 100 kmph to 0 kmph at the same rate and at the same time. So they both are not just cars moving at same rate, same speed. So can Tesla be considered as a machine, or still is it a robot? Be spontaneous and spot on, guys. Robot. Oh, why not a machine? Oh, since okay, Vanilla. I guess you already know the answer, right? Yeah, please be silent. Others other than Vanilla. Okay. Why not a machine? I mean, they both are functioning in the same way. Nothing is happening. They are just decelerating. Can we consider Tesla as a machine? If not, if you want to consider it as a robot, what makes it distinct from being distinct from a normal car? Any answer, guys? Any thoughts? Any approaches? Anything silly? It doesn't matter. All that matters is your thinking. Any thoughts on this? Don't give it too. Don't go to too stretchy. Don't be too stretchy. Just stick with the basics. That's what I suggest. I'll give you a hint if you want. Should I give a hint? Detects the presence of objects and decelerates on its own. Yeah, true. Anirudh, do you know the answer already, or did you just think it of right now at this moment?
I just got this idea right now.
Yeah, cool. Yeah, actually, that's the correct answer. Even though they are decelerating from 100 kmph to 0 kmph at the same rate. Yeah, Tesla is a self-driving car. It can map. It can autonomously navigate from one position to another position using GPS and many other tracking and sensing systems. Cool. Exactly. What Anirudh told is the exact answer. Still, the Tesla is considered as a robot because if you are not doing anything with the car, with both cars, if you place some object in the path, the normal car will just go and hit it. It will just crash. Whereas the Tesla car, it detects using the sensors, the sensory system present in it, and change its motion or decelerates at a faster rate or just moves away. I mean, it does something on its own based on the sensing done by the sensory system. So still, and that is what makes a Tesla into a robot. Am I clear, guys? Yeah, it changes its direction or its moment. Moment of path. Anything. It just changes. It deviates from the path of the normal car. Yeah. Okay, guys. Is that clear? Or should anyone? Does anyone want any better explanation? So this can be my answer. It can be a robot. No, not. It can be, but yeah, every self-driving car is considered as a robot. True. Yeah, it is one of the answers. I mean, yeah, it applies to the situation. Cool. Yeah, guys, that's it. How was the interactive session? Did you like it or you hated it? Did I push through so much? I would be happy if you just turn on your mics and say something. Okay, cool. I hope you liked it. So yeah, guys, that's it for today's session. Yeah, thank you. Cool. So I hope I made you think and continue exploring